Alright, so here we go, starting test number 9 review, our last test before our semester exam. Alright, so don't forget to make a note card. On the note card, I would at least have those perfect squares, probably through 1 through 20, your cubes 1 through 10, and through the fourth power 1 through 5. So like, saying 1 squared is 1, 2 squared is 4, 3 squared is 9, that type of thing. 1 cubed is 1, 2 cubed is 8, and that way you also know that if you have, if you need to go backwards, you can. Like, the cube root of 27 is 3, that type of thing. And here, like 2 to the 4th is 16, 3 to the 4th is 81, so kind of go from that. Okay? So that way you hopefully can get through those numbers a little quicker. So let's look at how do I solve this. Okay, so I'm going to be using the perfect square method. I might do a few of these problems by the factor tree, because I've seen some of y'all do the factor tree, just so that way you kind of get an idea. But kind of pay attention to which method you prefer. Okay, so square root of 28, perfect square that goes, the largest perfect square that goes into that is 4. 4 will go into it 7 times, and the square root of 4 is 2, square root of 7, and that's how we get my answer. So you're looking at that table that you have and seeing which of those can go into 28 and which is the largest one. So 25 didn't work, 16 didn't work, 9 didn't, 4 does. Here, if you start dividing, like you're using that perfect square table, 49 doesn't work, 36 doesn't work, 25 doesn't work, 16 does. 16 goes into 80 5 times. Square root of 16 is 4, square root of 5. So you need to kind of be careful on making sure that you know which ones are what, and kind of going from there. Okay? So on the next one, 252, don't worry about this negative, it'll be on the end. 36 is the largest number that goes into this, and it goes into it 7 times. So again, you would have gone through, like, say, all the ones that go there and kind of get like that. And then that's square root of 36 is 6, square root of 7, and not notice I'm just putting the variable on the end. Here, 27 would be 3, or 9 and 3, so square root of 9 is 3. This 3 needs to multiply this 5, so 5 times 3 is 15, square root of 3. 32 would be 16 and 2. Square root of 16 is 4, and then so I would say 4 times 7 is 28, with a 2 left over, and then there's just one x, so it just stays in there, okay, because it has to be pairs. 288 is 140. Well, is 144 is the largest that goes into 288, with a remainder of 2. Square root of 144 is 12. 12 times 3 is 36. Square root of 2. X's 1, 2, 3. I've got one group of x's that come out. I've got one x left over, so it'll stay there with the 2. Keep it company. Okay, and so there you go. Let me do these real quick with a factor tree, I guess, just for some of y'all that don't need it. I'll do number 2. Okay, so here, like, I may have gone 8 and 10, but that's 4 and 2. That's 2 and 2, that's 2 and 5, and you only look at the end branches. Pair of 2s, that's 2 times 2, square root of 5, 2 times 2 is 4, square root of 5. So you can see either way will still get you there the same way. Number 7, the largest perfect square. Okay, making sure, sorry. Now notice in number 7 we start with cube root. Okay, so now we're looking at the cubes table. So then I would be going, okay, 8, 27, 64, 8 goes into this. So the cube root of 8 goes into it 7 times. And the cube root of 8 is 2. Cube root of 7. Then 9 x's will give me 3 groups. 1, 2, 3. So x cubed. 7 y's will give me 2 groups with 1 y left over. So if you drew out 7 y's, you would have 2 groups of 3. Notice, based on the index, that's how many I want in a group. All right. So then 160 for the 4s, that would be again something like your 4s table, 81. Okay, 81 goes into this 2 times. So the 4th root of 80, or I'm sorry, the 4th root. I don't know why I'm writing 3rd root. 4th root of 81 is 3. 4th root of 2. Exodus 7 means 1, 2, 3, 4, 5, 6, 7. I get one group that I can take out. That's a group of 4, but I have 3 left over. And again, this index tells you how many you can have. Okay, so then I get to number 9, and I am going to say this goes into, again, cube root. So I discovered that's 125 that will go into it. And 125 will go into it 4 times. Cube root of 125 is 5. 5 times 3 will give me 15. Cube root of 4. X to the 5th gives me 1, 2, 3, 4, 5 x's. One group of x's with 2 left over. And there you go. Number 10, I've got a couple of different ways I can do this. What I usually like to do is go ahead and multiply and then simplify. So like 2 times 3 is 6. 12 times 8 is 96. And then 96, if I take the cube root of, or not cube root, square root, the largest perfect square that will go into 96 is 16. So I get 16, 96 divided by 16 is 6. Square root of 16 is 4. 4 times 6 is 24, square root of 6. And that's all you got to do for those. I'm going to do 11 and 12 over here because I had more space. So I could do the same thing here. I could do 3 times 5. I could do 3 and then 5 times 32. So I've got 3 square root. I'm going to change this to yellow. Ah! No! Okay, be careful on the backspace. That's what I now learned. Okay, anyways. So 5 times 32 is 160. Okay, so then I start looking for the largest perfect square that can divide into 160. And according to this, that would be 16 and 10. So this one kind of worked out nicely. Square root of 16 is 4. 4 times 3 is 12. Square root of 10. Notice how this never gets changed, the second one. Now I'm going to add or subtract here because these are the same. The square root of 5, I can say 7 minus 5 is 2. Square root of 5. 8 minus 7, or negative 8, I'm sorry, plus 5 gives me negative 3, square root of 7. Negative 9, okay, this one, notice, these are not the same, so now I need to simplify this 45. That's 9 and 5. And the square root of 9 is 3. 3 times 2 is 6. So now I'm actually saying negative 9 square root of 5 minus 6 square root of 5. Negative 9 minus 6 is negative 15 square root of 5. So those can be kind of easy like that. This one ends up being square root of 4 and square root of 7. Square root of 4 is 2. 2 times 6 is 12. So I'm saying here 12 square root of 7. So 12 plus 3 is 15 square root of 7. I kind of was trying to do with what limited space I had. Every time you see a negative, do not forget to put the I. All in favor say I. Yeah, couldn't resist. Anyways, you got here 9 and 2. The square root of 9 is 3 with a square root of 2 left over. Okay, so again, this whole perfect square method is trying to make sure y'all kind of get that. Okay, so here I've got square root of 60. So again, as soon as I see the square root, the negative, I've got that I. And then 60 is, well, let's see, what is 60? 60 is 4, square root of 4, and 60 divided by 4 is 15. So again, this is the largest perfect square that goes into it. Square root of 4 is 2, so I get 2i square root of 15. Here, this one is I. 63 is 9 square root of 7. So the square root of 9 is 3i square root of 7. 40 is going to be, again, we've got an I here. Notice, I'm not going to even worry about the 7 just yet. And you've got 4 and 10. Square root of 4 is 2. Now I'm going to say 2 times 7 is 14. I square root of 10. Here, let's see, that is going to be, that's a good question, 9 and 10. I'll worry about that in a second. Square root of 9 is 3. So 3 times 5 is 15. This will give me an I. And then you put square root of 10. Okay. So this is pretty much how these all work. I mean, here I've got 16 and 2. Square root of 16 is 4. 4 times 3 is 12. Then I've got the I. And then x cubed means I take out one group pair of x's, but I'm going to leave one left over with the 2. And again, it could be 12xi or 12ix. I'm not going to be picky on it. Actually, it should be 12xi. So let me erase that a little bit and say 12xi. I mean, I'm not going to count off for y'all, so don't worry. Here, 338 is going to be 169. So you see, I can come up with some funky numbers here. 169 and 2. So square root of 169 is 13. 13 times 4 is 52. X to the 6, that's 6 x's, will give me 3 groups. I square root of 2. I square root of 2. Okay. So there's all those simplifying and kind of getting from there. Then next, we've got the adder subtracts. So plus, there we go. Plus 8 plus 1i. Negative 5 plus 8 is negative 3. Positive 3. Negative 4 plus 1 is negative 3i. And you're done. 15 minus 5, so I'm going to put here negative 5 plus 9i. 15 minus 5 is 10. 9 plus 7 is 16i. Do-do-do-do. Okay, so when I have a minus, though, notice that the signs will change. So as I move the 6 under, I'm going to say plus 6 and plus 5i. Negative 7 plus 6 is negative 1 plus 10i. Remember, when the signs are different, you will take away. When the signs are the same, you will add. And you can type it in the calculator as negative 7 plus 6, and it should give you the right answer. 24, I'm going to say minus 11 plus 13i. And there's a 13. That looks like a B. Let's try that again. 13i. Okay, 17 minus 11 is 6. Negative 8 plus 13 is plus 5i. Okay, so those should be fairly easy. I mean, if I put those in there, you should get them. All right, so now let's look at number 25. 25 is, I'm going to put it up here. Okay, so I want to do this by multiplication. Remember, this will be a bonus on the test. So if I put it in here, it's going to be a bonus. So don't worry about that. Okay, when you do this multiplication, 2i times 8i, 2 times negative 8 is negative 16i squared. 2 times 3 is 6i. 0. 3 times negative 8 is negative 24i. And 3 times 3 is 9. Okay, so you got 9 minus 18i minus 16i squared. But I squared, don't forget, is negative 1. And negative times a negative becomes positive 16. So now I can add 9 and 16 to get 25 minus 18i. And that would be your answer. Okay? You need to be careful on that one. I mean, again, it's bonus, so you got to get it all right. So kind of go from there. The 26, did I give myself space? Of course I didn't give myself space. Why not? Because, you know, that's just more fun. Okay, so I'm going to erase this right here. And 26, I would multiply by negative 5i, because I always want to multiply by the opposite. When I do that, I'm going to get 5i times negative 5i is negative 25i squared, which will become positive 25. Negative 5 times 10 is negative 50. I'm sorry, positive 50i. 9 times negative 5 is negative 45. I squared. I squared will become a negative, -1, so that becomes 50I plus 45. Okay, switch it around, so I'm going to say 45 plus 50I because I want the I number second. All three of those numbers are divisible by 5, so 9 plus 10I over 5. That would be perfectly fine for an answer. Notice how that compares to that one. Okay, so that could save you a lot of time if you see the pattern. I'm not going to tell it to you. I want you to see it. So on this one, you end up with it. Well, let me let y'all test that pattern. Okay, but if I multiply by -7I, I end up with 49, and I'm going to end up with, let's see here, -49I plus 56I squared, which will become -56. So I've got -49I minus 56 over 49. Switch everything around. I now have -56 minus 49I over 49, which will simplify to -8 minus 7I over 7. And again, I'm not going to worry about trying to simplify that further. Y'all can do, leave it like that. Okay? The last parts should go fairly easy, so I do apologize that this one's getting kind of long. But here, simple. Once you got the square by itself, you can just say what's the square root, and square root of 81 is 9. But don't forget, you got to put plus and minus. The x squared has to be by itself before you can say do that. So here I got x squared is equal to -36. And when you take the square root of that, don't forget the negative means you've got an I. Square root of 36 is 6. And then you put plus and minus. So it'll be plus and minus 6I. Did I leave myself space for 30? No, I did not leave myself space for 30. Okay, so I'm going to put 30 over, like right up here. So I need to subtract 8. So I get 2b squared is equal to 40 because I said -8 minus 8. Divide by 2. Now I'm saying b squared is equal to 20. Then take the square root. And that simplifies, that's 4 and 5. Square root of 4 is 2. So I have plus and minus 2 square root of 5. That's what that's equal to. Kind of ran out of space, but you kind of get the idea, I hope. Here, subtract 8. You get 3r squared is equal to 150 negative. Divide by 3. R squared is equal to -50. Take the square root, and then r will be plus and minus 5 square root of 2. I got a little tongue-tied there. So how are these different than the square root ones? Well, the square root ones just ask you to square them. So again, 9 squared is 81. That's it. Now always make sure your plus, that you get the square root by itself before you say solve it. So this one I have to add 8 first, so I end up with the square root of x is equal to 25. Then when I square everything, I get x is equal to 625. But notice here, this square root is by itself. The -8 is part of that square root. So I want to square this, and I'll have x minus 8 equals 289. And then I can add 8 to that to get x equals 297. Okay, so now let me go back to here and do number 35 and say, okay, gotta get rid of this 2. So I have the square root of x plus 5 equals 7, because 14 divided by 2 is 7. Then take that, square that. So I got x plus 5 equals square 49. Then I can subtract 5 to get x is equal to 44. So a lot of this should be hopefully fairly easy. You just got to make sure you pay attention to the steps and recognize what steps you need to do. Beyond that, that's pretty much it, folks. I hope y'all do well on this test. I think y'all have been hopefully working hard on this and trying to understand it. And that's it for today. Thank you so much. Good luck.